Good afternoon, my dear students. Today we are going to see differential equations. There are two types of differential equations. One is ordinary differential equation, another one is partial differential equation. So ordinary differential equation we call ordinary, okay? Ordinary differential equations, right? When we have a variable dependent and a variable independent, we say it is a ordinary differential equation, right? More than one variable, we say it is partial differential equations, right? More than one variable, it is a partial differential equation. What is the definition of ordinary differential equation? A differential equation is an equation with one or more derivatives. What is derivative? We already see the derivatives which we have dealt in the first unit. D by dx, d square by dx square, and all these things are derivatives. And we say these derivatives occurs in an equation. What is an equation? Whenever a function equal arises, we say it is an equation. Something equal to something. So some d square, dy, we say when it is y is equal to f of x. Y is equal to f of x, we say this is an equation when you have this equal sign. Okay. So this is a differential equation where there exists dy by dx and d square y by dx square and so on, d square by dx square and so on. Okay. So in ordinary differential equation, we have more functions. See, for example, we have d square y by dx square plus 5 dy by dx plus 6y. This is the ordinary differential equation, which is of order 2 degree 1. Okay, the degree of this is 1. Okay, so we say we will deal with the order and the degree. Partial derivatives is somewhat though, and this thing we will see in the next chapter. General form of a second order differential equation is a d square y by dx square, where function we say that function we have d square, d, and some function x, y and x equal to some function of x. We will deal with these functions later. We will deal. D, capital D is d by dx. We denote this, right? We are so lazy. We want to solve the problem easily. We denote. This is a notation. When we say 1 by d, carefully, it is known as integral with respect to dx. Right? You have seen. X. You closely observe this constant, right? A. So D square is equal to, right? As soon as A, you write A square. D square is equal to minus A square. Okay, D square is equal to minus A square. Okay. Auxiliary equation, A square plus 2AB plus B square, that is M plus 1. M is equal to minus 1 comma minus 1. This is a equal roots. What is the use? Y is equal to A plus Bx into e power minus x. Okay, so this is the constant. Now write the complementary function e power x. Okay, that is what it is written here. After that, you write this, right? D square is minus 1, and plus 1 gets cancelled. 1 by 2d already said 1 by d is integration. Sin x minus cos x. So it is minus 1 by 2. To combine both, you get an answer. Okay. So you write a problem, different problem. See, this is d cube. It is a cubic equation. There is no square. How to write this? D cube minus or plus 0d square minus 7d plus 6y. Okay, that is the equation. There is, you write the coefficient here. Coefficient d cube coefficient is 1, d square coefficient is 0, d coefficient is minus 6 and plus 6. Okay, you see, you add this 6 plus 1, 7 minus 7. If this is this condition satisfied, then 1 will be a root. You put 1. This is synthetic division. You add this. 1 plus 0 is 1. You multiply this. 1 into 1 is 1. Add this 1. 1 into 1 is 1. You add this. Minus 7 plus 1 is minus 6. You multiply minus 6. 6 plus minus 6 is 0. So what are the roots? Now it is m square plus m minus 6. Okay. Now you solve that. We have 3 roots. We have 3 roots. Okay. Right. Write the equation A. Okay. The equation is a cubic equation. So whenever you have a third order differential equation, there will be 3 constants. There will be 3 roots. Right. You check with that 3, 3, 3. Okay. So this is for you to check for avoiding the careless mistake. Okay. Right. So Pi 1 by d cube, you write in the form of d square. Right. Okay. One simple method, you eradicate this. You multiply by d. Okay. So d divided by 6d. Okay. Forget about it. This won't work out. When you have again you have d. You multiply it by conjugate. 6 minus 11d into 6 plus 11d. 6 plus 11d. And you multiply and you can see. Okay. So 6 plus 11d. Okay, 6 square, a plus b into a minus b, a plus b into a minus b is a square minus b square, a square minus b square. You apply what is a is equal to 2 here, a is equal to 2 here. Okay, d square is equal to minus a square is equal to 4, 4d square is equal to minus 4. You apply and then you simplify. What is d? D is differentiation, right? You can do differentiation and you write the CF plus PI. I will share this PDF to the Google Classroom so that you can do the problem. Type 3 is polynomial. See, it's a polynomial. Type 3 is a polynomial. You can use polynomial. you use the binomial series 1 plus x power minus 1, 1 minus x plus x square minus x cube. If both are minus, what is 1 plus x power 1? 1 plus x power 1. What is 1 plus x power minus 1? 1 minus x plus x square minus x cube. 1 plus x power 1 is 1 plus x only. Don't confuse. Okay. Do the reality. Now it is pi. You know what is a complementary function. Now write the pi, right? So you have to convert this. You have to convert this into 1 plus something. So what you have to do? You write in the form of 1 plus 2d plus d square. Or otherwise you have to take the constant out. If it is what d square plus 2d plus 5, you have to take the 5 out. Okay, now you act this as 1 plus x. This is x. This is x. Okay, this is x. You differentiate and then you put x. You expand in series. See here, differentiation of x is 1. Differentiation of x is 1. D square is 0. So here we can eradicate this d square. You can eradicate this d square. 1 minus 2d plus 4d square. So this are eradicated. Okay. So 1 plus minus 2d plus 4d square. What is d? D is 1. What is d square? Again this d square is 0. Again this d square is 0. So 1 minus 2d, that is x minus 2. Okay. So dq, higher powers are 0. So these are the 3 types, major types, and other types are the combination. Other types are the combination of these e power ax. So e power minus ax cos ax. This is the combination of both f of x. We have the combination of f of x. Okay, e power ax. What do we call? We call it as shifting theorem. Shifting theorem. Shifting theorem. E power ax. It can be sin x or cos x or x. Okay. Replace d by d plus a. If you have e power minus 2, you replace d by d minus 2. D by d minus 2. Replace d by d minus 2. To differentiate d square minus 2d plus 7y e power 3x cos 2x. You differentiate, you find the roots. You use the calculator. M square minus 2m. Okay. What is a? A is 1. A is 1. B is minus 2. C is 7. Okay. The root is 1. 1. Okay. A is 1, B is minus 2, C is 7. Okay, so 1 plus root 6. This is the roots. You do this 50% of the problem is over when you find the complementary function. You see here we have e power 3x, e power 3x. I have shifted this e power 3x to here. Upon shifting, you replace d by d plus 3 and then you can do, okay. And then you can expand, you can do the process. Okay, you can do the process, right? So this is the same case for all the problem. Okay, same case for all the problems, right? Okay, we will do more problems, more classes. With this, we can complete. Okay, right?